In today's lesson, we'll be taking a look at even, odd, and neither for functions. And what we'll be looking to do is determine if functions are even, odd, or neither algebraically. It's in most cases easier to determine even, odd, and neither from the graph of the function, but sometimes it is not easy or feasible to make the graph. So having an algebraic technique to fall back on can be very, very useful. So what we will do today is we will look at the algebraic techniques, and then we'll just demonstrate with a couple of examples. So in both cases, to determine if a function is even, odd, or neither, we are going to replace x with the opposite of x in the function. And this works for both tests, testing for even and testing for odd. Let me rewrite that a little bit so it comes out a little bit better. Function. So that's our first step. And really where it comes out to play is what does the result look like after we make that substitution? We'll get a couple of things that are possible. What do the results of that substitution look like? Well, the first case, if that replacement, which we call f of negative x, if that can be rewritten and simplified, and we get the function back that we started with, if we can replace x with negative x, perform some algebraic simplifying steps, and get our original function back, then the function is even. If, however, when we make the substitution, replacing x with negative x in the function, the result gives us the opposite of the entire function. So we'd put the negative x in for x, perform some steps, and we end up with the opposite of what we started with, our original function x. Then the function is odd. A third possibility, if neither of these happen, then the function is neither odd nor even. And a function can't be even and odd. It's either going to be even or odd, so we don't have to worry about both of them happening. So that's what we're saying. It might not make a lot of sense, but let's demonstrate what that looks like when we actually apply that. So our real basic step, we only have to do one thing. We have to replace x with negative x in a function. So wherever you start with some x in a function, we are going to replace it with the opposite of x, then perform some algebra on it, and really is what do we do with those results, and how do we interpret those results, and what do those mean to us? So let's take a look at our first example. Example 1 says, algebraically determine if f of x equals x squared minus 3 is even, odd, or neither. So my function, f of x equals x squared minus 3. So if I look at where the x's are, I have an x right here and an x right here. Well, our test tells us to replace x with the opposite of x. So in the function name, instead of having f of x, I'm going to have f of negative x. And I'm also going to have, instead of x squared, I'm going to replace negative x squared. Replace it with negative x and square it. Some of the question might be, do I need parentheses around the negative x or not? In general, parentheses are a good idea for substitutions. In this case, in the original problem, I am squaring all of x, so I want to square all of its replacements. So here, all of x is being squared, so I want to square all of its replacements. So I'm going to go ahead and use parentheses. Now what I'll do is I'm going to go ahead and do some simplifying. Negative x squared is negative x times negative x minus 3. Negative x times negative x is a positive x squared minus 3. And what I notice here is that now my result, the x squared minus 3 that I have, is exactly the same as what I started with. So I can make a further note here, one extra line that says that is f of x, because because x squared minus 3 is equal to f of x. I can say that those two things are equal. And then, kind of by the transitive property I got going on now, so f of negative x, all the way down to here, is equal to f of x. And that was our test when we interpreted the results. I'm going to go back for one slide. If I look at how we interpret the results, I'm having some smartboard issues here. Sorry about that. There we go. If I look at the first result, if f of negative x is the same as what I started with, then the function is even. So if I look at this, I got that result. So I can make a little statement here, and I can say, so the function f is even, because it passed this algebraic test. If we went ahead and graphed and applied the graphic test, which you may or may not have seen before, we would get the same result, that it is an even function. Since we do know it's an even function, we really don't have to go on for any other tests for the odd test, but let's demonstrate it just to get some practice with it. So I am going to erase what I have here and perform the, well, the odd test would look the same, so I guess we don't need to perform that. Let's just go to another example. Example 2, algebraically determine if f of x equals x to the 5th minus x cubed. So like we're seeing here, this could be a difficult function to graph depending on where you are in your mathematical career. X to the 5th minus x cubed for some people is a very easy graph to make. For others, a very difficult graph to make. If it's for you, it's a difficult graph to make. Good thing we have the algebraic technique here. Our statement, our rules, our test says replace x with negative x. So everywhere I have an x in the original function, right there, right there, right there, I'm going to replace all of those x's with negative x's, and I'm going to use parentheses just like I did before, x to the 5th minus negative x cubed. So this is really where parentheses become kind of important, and we want to make sure we have the right number of parentheses and negatives and so on. Applying algebra, negative x to the 5th is negative x to the 5th. Now it's going to be minus a negative x cubed, which simplifies to negative x to the 5th plus x cubed, which does not look like the original function at all. In the original function had x to the 5th minus x cubed. Here I have a negative x to the 5th plus x cubed. But I do note that I have the same terms with opposite signs, which means I can factor out a negative 1 and say it's really x to the 5th minus x cubed. And remember that you can check factoring by using the distributive property. If I redistribute the negative, I would have the negative x to the 5th plus x to the cubed in the above line. So I know that they are, I factored correctly there. So I have that. And what I see now is that this, what I have in the parentheses, x to the 5th minus x cubed, is this piece right here. But I have a negative out in front of it. So that means that my last line of my work is the opposite of the original function f of x that I started with. And since I end up with that opposite, if I take this and just this, that means I started with f of negative x, did a bunch of work to it, and ended up with negative f of x. And looking at my results again, that tells me that's the result in purple. If f of negative x can be rewritten as negative f of x, then the function is odd. So in this particular case, I was able to take f of negative x, rewrite it as negative f of x. So I can say, in this case, this function is an odd function. Okay. Just a quick go over on the rules, a couple of examples. We'll have a chance for a little more practice when we come into class, at least for my class. But I hope you found this little introduction to even, odd, neither helpful.